Good afternoon, all distinguished guests and participants. I, Professor Viresh B, along with my colleague, Professor Jyoti BK, welcome you all to this keynote session of ICIEA 2022. Firstly, I would like to introduce the keynote speaker, Dr. Boi Tan Hung, Professor at Dao Mot University, Vietnam. Welcome, sir. So kindly unmute your mic, sir.
Good afternoon, everyone. Can you hear me?
Yeah. Welcome, sir.
Okay, right.
It's my indeed a privilege to introduce the keynote speaker, Dr. Boi Tan Hung. Sir has received his MS degree and PhD degree from Japan Advanced Institute of Science and Technology in 2010 and 2013. He is currently a researcher at Faculty of Information Technology, Ton Dak Ton University. He is also the director of Data Analytics and Artificial Intelligence Laboratory, DAAI Lab at Dao Mot University. Sir has completed 2 projects, published 52 journals, 13 book chapters, 35 international conference papers, and 15 domestic conference papers. Sir has 3 best awards of FICTA 2018, RICE 2020, and ICAIA 2021, and was selected as Excellent Scientific Researcher of Dao Mot University in 2019, 2020, and 2021. Sir is a reviewer of many reputed index journals and conferences. He has also served as a keynote speaker for many international conferences and traveled across countries. Sir, areas of interest includes natural language processing, machine learning, machine translation, text processing, data analytics, image processing, and artificial intelligence. It's a privilege to have you with us, sir. Well, I welcome you to the keynote session, sir.
Thank you for your. Please give me share my screen.
So now I request to deliver the keynote address, sir.
Yeah, but I can't share my screen. Can you give me the admin to share my screen?
Just a moment, sir. Just a moment, sir. Just a moment.
Okay. Good afternoon. Good afternoon, everyone. Today, I would like to present with you about the keynote speaker with the title "Graph Neural Network for Intelligent Systems."
So kindly check it, sir. You have been now you can share your screen, sir.
If not, it doesn't start.
So you are able to share the screen, sir, now?
Okay. Okay, now it's work now. Okay. Can you see my slide?
Yes. Yes, sir. It's visible.
Sorry, I just moved to a new university, the Tolbekang University, in this year. So the information is updated now. Here is outline of my presentation, but I will talk about the intelligent system and graph neural network and how to use graph neural network for the intelligent system. And lastly, I will need conclusion. Now let's start with the intelligent system. What is intelligent system? That we are in the industry 4. We industry 4 with an industry 4 with some main view here with the big data, AI, artificial intelligence, internet of things, and data. So there are many so problem in the key core.
Sir, you have so kindly unmute, sir.
Okay. Smart government, mobility, smart digital, smart health, smart agriculture, and other. So, what is the intelligence system here? We have the reply for developing one intelligence system, which the first phase is a representation, and the second is a computation, and the last is a discrimination. So in the intelligence system, complex and with the wide range of technical, for example, AI, artificial intelligence, machine learning, deep learning, natural language processing, computer vision, speed processing, embedding CPU, distributed storage, wireless networking. And take a look about natural language processing in the intelligence system. We know that now social network is very famous with a lot of big companies, for example, Facebook, YouTube, LinkedIn. Yes. And in natural language processing, there are a lot that in the natural language processing. You can see in the last column, in the third column, it's related to linguistic, for example, tokenize, STEAM, part of speech, passing, and in the mid is a intermediate task in the natural language processing. For example, information retrieval or adjection, name entity recognition, sentiment analysis, word sense and with ambiguation, discord analysis. And the third column is the advanced natural language processing, for example, machine translation, automatic summarization, natural language generation, question answering system, dialogue system, or image captioner, and other multimodal tasks. And in the computer vision, with a lot of tasks in the computer vision, for example, related to the human with the face detection, face recognition, handwriting recognition, hand recognition. Here the action recognition. Yeah, and a lot of that in the computer vision. How about in the voice processing? We know that there are some famous voice assistants from the big company, Apple Siri, Google Now, Amazon Alexa, Microsoft Cortana, or Google Assistant. Yes, and by the global speed and voice recognition master side, they said that in the North American speed voice recognition market with a lot of money in this area. So in this talk, I will talk about how to use the graph neural network to build the recommender system, one of the intelligent system. Now, take a look about the graph neural network. What is graph neural network? First, we will define embedding node. What is embedding node? Embedding node, it means that we will unfold node similarity in the embedding space, approximate similarity in the original network. We have here is the original network, and here is the embedding state. How to do that? We need to define a similarity function from the original network to the embedding state. And we can use the encoder map node to allow dimension vector. And similarly function will specify how relation in the vectors map to relationship in the origin network. We can use slow encoding, for example, with the embedding logic and embedding vector for specific node, and we can have we will have the dimension size of embedding here. However, embedding node has some limitation. The first is we need the parameter, and the second is the chance G, and the last is it doesn't incorporate node picture. So how about the deeper method based on graph neural network? So first we have to build graph first. Assume we have a graph C with the V is the vertex set and A is the adjacency matrix, and we had the matrix node a picture with the, for example, a categorical attribute like image data, a node degree, or clustering coefficient, or indicator vector. So we will define neighborhood aggregation. The key idea here is we generate the node embedding based on local neighborhood. So the node aggregation emotion from the neighbors when using neural network, and every node will define a unique computation graph. So neighborhood aggregation, the node has an embedding at the each node, and model can be arbitrary deep. And layer 0, it embedding of node is input picture. And neighborhood convolution. What is neighborhood convolution? Neighborhood aggregation can be viewed as a center surround filter, and so that we can build the neighborhood convolution. Yeah, you can see that here. 1, 2, 3, 4. And to build the neighborhood aggregation, the key distinction here is how different approaches aggregate information across layer. What in the box here. So we can apply with the basic approach the average neighbor information and apply a neural network. The first we will average the message from the neighbor, and like we apply the neural network. And with the basic approach, we will average neighbor information and apply a neural network. And you can see that here is in the 3-layer embedding, and here is a non-linearity, and we have the average of neighbor in the previous layer embedding, and it means that the previous layer embedding, and here the infinity layer embedding, and we can define the neighborhood aggregation function. So how to change the model to generate high quality embedding? So we need to define a load function on the embedding. To change the model, after 3 layers of neighborhood aggregation, we get the output embedding for each node, and it means that we can fit this embedding into any load function and run to store gradient descent to change the aggregation parameter. To change the model, it means that we use the unsupervised manner in the graph structure, and with the unsupervised load function, we can deal with anything. For example, based on random walk, some famous here is the node to vec, deep walk, graph factorization. We can change the model that's similar node has similar embedding. And so here overview of model design. First, we had defined a neighborhood aggregation function and next define a load function on the embedding. And we chain on a set of nodes a bed of composite graph. And next we generate embedding for node. However, even the node we never chain it on, we can use the aggregating neighborhood information to do that for the even node we never chain on. So it will allow for parameter sharing in the encoder and allow for inductive learning. And in the graph neural network, we will use the inductive capability. What is inductive capability? Here we chain on one graph, and we have an inductive node embedding, and we can generalize to entirely unseen graph. Yes, is the inductive capability. And I will present two famous graph neural network. The first is graph convolution network, and the second is graph saga. Graph convolution network proposed by Kip et al. 2017, and here is the function neighborhood aggregation. Take a look about we had the basic neighborhood aggregation, and now GCN. What is the difference between the basic neighborhood aggregation? We see that here is the same magic for cell and neighbor embedding. And take a look, we can see that some difference between the graph convolution network with the basic neighborhood aggregation. And with the graph convolution network, this model will give the bacteria because more parameter sharing and the downweight high degree neighbor. And graph convolution network can be efficiently using a sparse path operation. So the time the complexity overall. So take a look about the first model, graph convolution network. Convolutional network. It's different with the basic neighborhood aggregation. And the second is the graph saga idea. The graph saga. What is different is graph saga? We had aggregated the neighbor message by the checking their weight average. So can we do the better? With the graph saga, any different variable function can map set of a vector to a single vector. And what is the difference between the graph saga with the symbol neighborhood aggregation? We have the symbol neighborhood aggregation here, and here is the graph saga. And we see that they use the context the cell embedding and neighbor embedding with the generalized aggregation. And the mean they use the IGZ and the phone which transform neighbor vector and supply symmetric vector function. And they apply LSTM to random permutation of the neighbor. So I just present about the graph neural network with the two. The first is a basic model, and the second some two detailed model, graph convolution network and graph saga. And now we will apply graph neural network to show to build the intelligent system. Here I want to focus on the recommender system. You know that on the big company Amazon, Yahoo, Twitter, use the recommender system. It means that it is we will use the recommender system to recommend to the for the product website, log on new item to the user. And recommended system will reduce the information by the estimating relevant. And from the user profile and conceptual parameter, we use the recommendation component to get the recommendation list. And we can apply with the collaborative method. It means that tell me what popular among the my peer. And the second approach here we can apply by the content by method. What is the content by? Content by means that show me more the same what I like. Another approach we can apply here is a knowledge base. It means that tell me what fit based on my needs. And the last approach is a hybrid. It means that we can combine period input composition of different mechanics to solve the problem of the recommended system. And why graph neural network here is useful for recommendation? Because that's the first GNN technique has been demonstrated that is powerful in representative learning for graph data in various domains. And the mode of the data in recommended system has a scenario on a graph structure. Now take a look. Here we have the user item by partition graph, and here is sequence graph, and like a social relation between user and knowledge graph. So to build recommender system based on GNN, we can do by two approaches. The first is a general recommendation, and the second is a sequential recommendation. With the general recommendation, it means that we win to the model user person by leverage user item interaction data and provide a list of recommendations reflect the static long-term interest of each user. And with the second approach, sequential recommendation, we will capture chances in pattern in the second for next item recommendation. Now take a look. We for the GNN by recommendation, we have the two approach here. And in general recommendation, we can use the user item interaction information, social network enhanced, knowledge graph enhanced. And in the sequential recommendation, we can talk more detail in later with the second information, social network enhanced or knowledge graph enhanced. So with the first user item interaction, we see that there are a lot of research apply graph neural network in the big conference here. You can see that big conference in the artificial intelligence or big data. For example, in TDD, ICDM, AAAI, yes, various of GCN model apply to solve the to build the user item interaction. And with the user item interaction and social network, here is some research in 2019 and 2020. And user item interaction with the knowledge graph is a lot of research. In the first approach, how to build the user item interaction, we need to define graph construction, neighbor aggregation, information update, and final node representation. How to solve this problem? With the graph construction, we can use many ways to build the graph. And the famous graph here is by partial graph. Almost user choose to build the graph construction. However, another kind of graph also apply in this tool. So we had to symbol represent enable for the graph propagation. And the framework of GNN for user item by partial graph here. So is so in this slide you can see we build the chef graph and take a user node And the final here is the user item representation. And next is how about the neighbor aggregation? Because the difference of the neighbor, so that the model and activity between the center node and neighbor are interacting among the neighbor is very different. So how to build the neighbor aggregation here? And the last is information update, how to integrate the center node representation and the aggregation to representation of each neighbor is very important. And the final node representation, how to predict the user preference for the item require the overall user item representation. Yeah, and if you apply in this approach, you have to solve own problem here. And the second with the social network enhanced, and in the social network enhanced, we apply two strategy for social enhanced general recommendation. And we incorporate the relationship between the user into interaction behavior by leverage GNN. And there are two main issues to deal with. The first is the influence of brand and the preference integration. And with the first influence of brand, it means that brand has an equal influence. If not, we have to distinguish the influence of different brands. And for the preference in integration, the user are involved in the two type of relationship, so that how to integrate the user reference from the social influence perplexity and interaction behavior is very important to social network enhance. And the last is the knowledge graph enhancing. It means that we had to enhance the knowledge graph to recommender system. And we had to deal with the graph constructing and relation aware aggregation in the knowledge graph enhancing. So the first, the approach general recommendation apply based on GNN for the recommended system. And the second is a sequential recommendation. We certify what is a sequential recommendation, and almost previous research focus on inferring temporal preference only from the sequencing. And you can see that there are a lot of research about the sequential recommendation here. With the sequential recommendation, here is framework of CNN in the sequential recommendation. You can see that, yeah, with the user behavior sequencing, we view the GNN block and sequential block and next prediction task. And in the sequential recommendation, we had to solve three problems. The first is how to build the graph. The second is information propagation, and the last is sequential preference. Yes, the first, how to build graph is very important. Sometimes your data is the image or video or speech or text, and so how to build the graph, because if we don't have a graph, we can use the graph neural network to solve the problem. And the second is information propagation, because we had to capture the transition pattern, and which kind of propagation mechanic is appropriate, and we need to define this information propagation in the graph neural network. And the last is sequential preference, because we want to get the user temporal preference. So the representation in the sequential should be integrated. How to apply attention pooling or leverage INN shock to the enhanced consecutive time pattern. Yes. And another recommendation that here is, for example, some recommended that for example, point recommendation and group recommendation. What is point? And another is the click-through rate prediction. Yes. And point, it means that point of interest recommendation. And another is a group recommendation. And there are some research related to another data recommender system here, point. And on the main conference in the computer science, you can see that here. So I just show you there are a lot of work related to using graph neural network to show to build the information system, and on more research here in published in the first rank computer and journal. So that if you want to see more detail, please check in the paper to get more detail about its model. So graph neural network method is a useful model for to build the intelligent system. And however, graph neural network is with a large amount of computation and data with little engineering by hand. And up to now, various graph neural network have become the new state of the art method for to solving many problems of natural language processing, recommender system, computer vision, or speech processing. And you know that supervised learning is the most popular practice. However, graph neural network is belong to deep unsupervised method, so that is more difficult than the other. So here is some reference to my presentation here. And the last is even every day the change becomes the most beautiful day of your life. And on my publication, so on my slide, you can check on my slide. And I had some publication related to graph neural network in last year and this year. You can see that here. Okay, thank you for your attention.
Thank you, sir. Thank you for the keynote address. Is there any queries from the participants? Is there any queries so that the sir can answer your queries?
Yeah. Maybe this topic is more difficult, and you see that on publication here in the top rank computer and journal, and it's a little different, difficult. So that is for undergraduate students, maybe it's difficult to them. I think so.
Yes, sir. So I'll take it as a no for the participants. So thank you, sir. Thank you for your knowledge-enriched keynote address.
Yeah.
So now I request all the participants. Our second keynote speaker will be joined in 5 minutes. So kindly wait.
Okay. Thank you. And if you have any question, you can contact me by the email later.
Yeah, now you have my voice, yes? Is it right?
Yeah, yes, sir.
Okay. At the first of all, I want to thanks for organizing of this conference, the International Conference on Intelligent Engineering Approach. My name is Javad Rahebi. I'm a professor in the Istanbul Ayvan Saray University in Istanbul from Turkey. And today I want to talk about some details about the intelligent systems in the engineering. And my specialized about the deep learning and optimization methods. And
the lowest frequency of music or sound that every creature on earth can hear. Shruti, ಇಲ್ಲ ಅಂದ್ರೆ 4 ವೇದಾಸ್ ಅದಾವಲ್ರಿ ಎಲ್ಲಾ ವೇದಾಸ್ ಕಲ್ತ್ಬಿಟ್ಟು ಶ್ರುತೀಸ್ ಅಂತಾರೆ.
Sorry, I didn't understand.
Sorry for the interruption, sir. It was a mistake from the participant side. So I request
okay.
the participants to mute your mic.
Okay. No problem. From Turkey, let me explain some things, some information from the Turkey, from Istanbul. And in the Turkey, we are in the university, we are working on the data identification and the interpretations. And also in the last years, you know, about the COVID-19, we are working on some projects to reducing of the patients and also organizing of these patients in the hospitals by the blockchain. And also we use the deep learning and also artificial intelligence to controlling of these patients in the hospitals. You know, the data is so huge in the last years, and also we cannot control all of them, but we use the data as a blockchain data, and we can control all of them easily and comfortably. Also, our teams working on the data identification, as I explained, and also data analyzing. That's so important in our decade and also our lives. And we use the new deep learning methods. And also we implement this deep learning with the optimization methods like the heuristic methods, like the chameleon optimization methods and the gray wolf or other heuristic methods to reducing the feature numbers from the data. And we are optimizing this data to put in the deep learning and to put in the artificial intelligence to classify and get the good results. My specialist, as I told, I'm working on the deep learning and also artificial intelligence. So I want to contribute with the Indian universities and also the Turkey universities to collaborate the projects between the both universities. We can use the some famous software like the MATLAB, like the Python, like the other software that we can implement the deep learning and also artificial intelligence in the models. I hope this conference will be help us to improving our relation between the India and also the Turkey universities, and we can work together. We can introduce some projects like the European projects, because we have European project in the Turkey, and we can implement together with the your universities and our university to get the high accuracy and high performance for our projects. For this reason, I think this conference will be help us about this issue. And also in the future, we will get some data from the hospital, from the Turkey hospitals, because now we are working on these projects to get the tunable data and also Affin data, and to transfer to other countries to get the experimental issues. And nowadays also, this is the first options about the hospital and about the diesels. Other options about we are working also in the energy side, in the solar energy and wind turbine energy, renewable energy, and also electrical vehicle. And we have some projects and some PhD theses related to these topics. And we are organizing to implement the new model for the renewable energy that's used in the electrical vehicles. Also, we have some projects under this the details, and we are using the deep learning and artificial intelligence under this field. I hope because I visit India under 2018, April 2018, and I visit in the Chennai University, and also New Delhi. I visited in the New Delhi, and I saw in the India they are working on the renewable energy, and it was very interesting for me. And they got huge information and also huge experiments under this field. I hope in the future we have the connection in your universities and also the Turkey University to get the high performance about the implementation of this experimentals issue. And I want to thanks again from the organizing of this conference. Really, it's a very good conference, and also the best, my best friend, Professor Parameshwari, he organized this conference, and really I appreciate for him and for inviting of me to this conference. Thank you very much. Thank you so much. And if you have any question, I can answer for you about the my specification.
Dear participants, if you have any queries.
No, thank you. Thank you very much. And I hope this conference will be so benefit for all the professors, the students, and all the participants that attend to this conference.
Thank you, sir. Thank you for the knowledge and address, sir. I thank you wholeheartedly, sir, from our institution.
Thank you. Thank you so much. Thank you so much.
So, dear participants, if you have any queries.
Hello, sir. Hello.
Hello, hello.
Yeah, I had one query, sir. Just now you told that India and Turkey, we can have a collaboration and we can do the projects. Can you brief how we can proceed with that?
Yes, about the projects, we can start from the solar energy and also wind turbine and renewable energy, biomass. Really, we need this issue in our countries and also in the Europe side. And we want to collaborate about this issue. I think there is a big gap between the technology and also our application in the Turkey, and we can collaborate this issue from the Indian universities to research and also bring the technology to Turkey and implement in the Europe side of the Turkey, in the Istanbul. You know, the Istanbul site is the depend to the Europe side, and we can implement and we can bring the some companies from the Europe to see this technology in the Turkey. That's mean we can work together, and you can come to here. I will invite you to here, to Turkey, to visit here, and we can implement the renewable energy that will be used in the future for the electrical vehicles and also in the industrial. I think it will be so important for us to in the future to use this technology. My recommendation is we use at the first we start from the solar energy systems.
Hello. Hello. Hello.
Yes, yes.
Yeah. Good afternoon, sir. Hello.
Yes, yes. I have
Yeah.
your voice, but there is some interrupting.
Sir, is it audible? Hello.
Yes, yes. I have your voice.
Yeah. Good afternoon, sir. This is Shivkumar from Mechanical Department, SL Engineering College, Raichur. The host
Good,
institution. Yeah. Sir, you were talking related to renewable energy resources.
Yes.
Sir, can our institute have a tie-up with your university for UG projects on renewable energy?
Sure. Actually, we need this issue. You can contact your university contact with me, and we can put the meeting.
Sir, my query is whether as an institute can we have a collaboration with your university?
Hi, you mean your institute can collaborate? Yes.
Yeah.
Very good. Perfect. Because we need at this moment.
Yes.
We need the energy, especially in the renewable energy, as I explained, and we need the good high powers. And because maximum power point tracking methods now they are implementing in the methods, and we need the high power with the low specificity.
Yeah. Sir, can as an institute can we send you a request to?
Sure.
Yeah.
Please,
Sir, that
contact
is
me.
very that is very nice of you, sir, and we expect your cooperation in this.
Yes, it will be so good for us, and I will appreciate for your contacting. And also, at the first you contact with my university or with my email address, and then I can put our head of the university and also other university, because I'm working with them. I have relation with the many university in the government, private university in the Turkey. And I have a good connection with them. We can open the road for you, and we can open the way to coming to here and to use your technology in the here, and also we can implement the big project in the here.
Yeah. Thank you, sir. Thank you very much.
You are welcome.
Yeah.
Yes, if you have any query, you can send for me. You can contact with me, and also you can contact with the Professor Parameshwari, and because he's my best friend in the India, in the Chennai, and really I appreciate for himself to inviting me to the conference, and you can contact with him or with me. It's not important, and we can collaborate together in the big projects between the Europe side and the Asian side. I mean, the India and Turkey, we can connect for doing the good projects and also the good implementation this side.
Dear participants, have any queries? Any other participants have queries? So shall we end the session with your permission, sir?
Sorry, I didn't see your voice. I did have your voice.
So shall we?
I don't have any query from the participant. Thank you again. Okay. Thank you very much for putting in this Zoom applications. And I hope in the future, after pandemic, I can come to India or you come to Turkey and we visit each other face to face.
Thank you, sir. So we thank you, the keynote speakers, Dr. Bui Tang Hung and Dr. Javed Rahibi, sir. And thank you all the participants for attending this keynote session. Here is a small announcement. The paper presentation sessions will be continued as per the details shared to the respective authors. Thank you all, sir. Sir, with your permission, shall we end the session, sir? Javed, sir?
Thank you. Thank you very much. Thank you.
Thank you, sir. Thank you.